A very good morning to all of you. I hope you all are doing well today. My name is Ushaka Fernando and I'm thrilled to be here today with my fellow group members, Marsha.
Hi.
Chamali.
Hi.
Nirmani. Subodha. We are excited to present to you today on the fascinating topic of significance of studying the language-related regions in the brain, how these areas work, how scientists study them using methods like looking at the brain after someone has passed away, checking brain waves with EEGs, and using a machine called fMRI. We hope to discuss each method and share why they help us to learn about how our brain processes language. We hope you find our presentation insightful and engaging. Our presentation will last for about 20 minutes. If you have any questions, feel free to ask the questions at the end of our presentation. Let's take a look at the outline of today's presentation. Introduction, language-related regions, methods of studying the brain, advantages and disadvantages of the methods, and overview of methods. Let's move to the content slide. Significance of studying the language-related regions in the brain will be presented by me. Postmortem will be presented by Marsha. fMRI will be presented by Chamali. EEGs will be presented by Nirmani, and analysis will be presented by Subodha. Let's get started with the introduction of today's presentation. What is human brain? It's an incredibly complex vital organ in our body, weighing around 3 pounds. It serves as the command center of the body, controlling our emotions, thoughts, and bodily functions. Have you ever wondered what can happen if your brain is damaged? When the brain gets damaged, it can cause different problems with our body and thinking, depending on where and how bad the injury is. Our brain is composed of various regions, each playing a unique role in different functions. Today I'm going to talk about what are the language-related regions in the brain. They are also known as language centers in the brain, namely Broca's area and Wernicke's area. Broca's area is located in the frontal lobe of left hemisphere, while the Wernicke's area is located in the temporal lobe of left hemisphere. These two areas are really important for things like understanding what other people say, speaking, and putting words into sentences. Let's talk about the Broca's area. It's located in the front part of the brain and it helps us to speak. It's responsible for language production. If this area gets damaged, it can make it hard for people to speak smoothly and make sense when they talk. When it comes to Wernicke's area, it's located in the back part of the brain and it helps us understand language. If there's a problem with Wernicke's area, people might have trouble understanding what other people say, and when they talk, they might use wrong phrases or words. Now let's see the significance of studying the language-related regions in the brain. Basically, it helps researchers and experts understand how our brain processes language, providing insights to cognitive functions such as perception, memory, and attention. And also it helps teachers understand how people learn languages and find better ways to teach them the language. And it helps scientists understand how our brain supports complex thinking processes related to language like understanding or speaking. And also it helps in diagnosing and treating communication disorders such as aphasia, dyslexia, and language processing disorders. And it can provide insights into neurological conditions like autism. It contributes to our understanding of brain's plasticity or the brain's ability. As I have shared my insights on the significance of studying the language-related regions in the brain, particularly focusing on Broca's area and Wernicke's area, I will now hand over to my colleague Marsha. She will dwell into post-mortem findings and discuss what are the different methods employed in studying these areas, providing an insightful overview. Over to you, Marsha.
Thank you, Shaka. So from now on, I will be going to present about the brain post-mortem. Before I proceed with my presentation, I would like to ask a small question from you. Do you know what a brain post-mortem is? Have you heard about a brain post-mortem? Yes? What do you think a brain post-mortem is?
It's an examination
When you're dead.
when you're dead to check whether you have been how you have died.
Yes. Okay, thank you. So let us see what a brain postmortem is. So a brain postmortem, as you said, is a thorough microscopic examination into the brain, and we use a dead or a deceased person's brain for this thorough microscopic examination in order to gain valuable insights of the bodily functions and to gain information about a person, right? So let us discuss some advantages about a brain postmortem. And just to mention, a postmortem is about a deceased person's body, but our module basically deals with the brain. So we are going to very specifically talk about a brain postmortem, how we use a dead person's brain in order to gather valuable insights and information regarding this particular person. Understand? Yes. So what are the advantages of doing a brain postmortem? So there are quite a few advantages of this old method, because a brain postmortem deals with flesh and blood. It's a lively thing. So it has a very high resolution, and we uses histological techniques in doing a brain postmortem, which means disease-causing symptoms and diseases can be observed through these histological techniques. And further, the brain postmortems give a real view or a realistic view of the brain, which means, especially like diseases, when it comes to diseases like Alzheimer's, tensions or lesions of the brain can only be observed through a brain postmortem. There are new techniques such as fMRIs and EGGs, but through these techniques, the brain's swelling and the reduced mass size can only be observed. But it is only through a post-mortem that the brain's tangles and the lesions can be observed. So now it's time to watch a short video clip regarding the histological techniques of the brain.
The brain is looked at instead in flesh and blood, when the real brain is looked at. There are techniques, they're called histological techniques. There are techniques to process these brains and to be able to then look at individual cells, look at individual fibers, and that's where you observe the pathologic phenomenon that creates the disease in the first place. For example, Alzheimer's disease, the symptoms are dementia and other organic symptoms. But when you look at the brain using MRI, you can see shriveling, you can see a loss in mass, but you don't really see the actual overt lesion of Alzheimer's, which are the plaques, the tangles. In order to see those, you have to work on post-mortem brains, post-mortem donated brains. And when you slice them, stain the slices, it's a procedure that's very it's actually an old procedure. It was histology started 200 years ago. But it is still the only way we have to look at individuals' cells, to look at processes that cause the disease, and it's extremely important, and it's still the gold standard. These days, of course, just like anything else, even this branch of neuroscience has entered.
So let us now discuss about some limitations of post-mortem. And since we all know every positive aspect of the world has their own limitations, so as I mentioned, we need to have a deceased person's brain in order to do a post-mortem. That is a very limiting factor. We have to basically wait till someone dies in order to take their brain and do this examination. And what's more limiting is that the consent. If the family does not give consent or the person has not already provided consent, it will be a limiting factor. And a dead brain cannot be compared to a living brain, because a dead brain is a dysfunctioning brain. It cannot generate thought. So bodily functions does not happen in a dead brain. So this is another limiting factor. Let us now watch another short video regarding the limitations of brain postmortem.
Over the years, there have been many theories about this area. But despite the occasional success of this method, you may have noticed a slight problem with it. And that's that it requires an autopsy to be performed, meaning that they have to wait until the person dies in order to confirm what areas of the brain are actually damaged. And as it turns out, that might take a while. Sometimes people with brain injuries live a long time. And maybe by the time the autopsy is performed, they may have sustained additional brain injuries that were unrelated to the original one, which can make it difficult to form any firm conclusions. It is also possible that the patient might outlive a curious doctor or scientist, or the patient could move away and lose touch. Or maybe the family might refuse an autopsy, or refuse to give doctors access to the brain or body. So while early doctors and scientists were able to learn a fair bit about the early functioning of the brain, the lack of control that they had over the injuries, and the time span over which this research needs to take place, made these methods really limited in terms of the conclusions that they could come to.
So now to talk about the modern methods and to talk about one of the modern methods, which is fMRIs, my colleague Chamali will enlighten you. Over to you, Chamali.
Thank you, Marsha. Welcome you all, and I know you already know one of a method of brain study called as postmortem, explained very clearly by Marsha. Now I will explain another method of study of brain called as fMRI. Now shall we move to the slide? Then try to have get some idea what it is like. Okay. Now here when we are taking a test or enjoying a cup of coffee, some certain parts of our brain are extra busy. So these red spot shows us such captured some activities taken by an fMRI. Did you notice it? Okay. Now shall we move to the next slide? And here these are the points I wish to explain for you about fMRI during my presentation. So then what is fMRI, how does it work, then about the history and the development and the practical applications, what are the advantages and disadvantages, like that. I'll give you an overall explanation about this. So before start my explanation, I'll show you a small video clip. Then you just watch this video and see how using fMRI technology, how detect the activities in the brain. Now watch this video carefully. By looking this video, you can see how it's happening. No? Yeah. Okay. Now this is the time I will start my explanation part. So fMRI stands for Functional Magnetic Resonance Imaging. Okay, Functional Magnetic Resonance Imaging. It's a type of a non-invasive brain imaging technology, as it helps to detect the brain activities by measuring changes in blood flow, as well as it helps to detect the activities in it helps to detect the activities in brain while some function is. As example, when lifting your arm or even just thinking something about, so be careful when you're thinking something about different, because fMR can reveal what part of the brain is active. So like that, fMR is a powerful tool used in neuroscience and medical researchers. Not only that, for psychologists, psychiatrists, educators, lesson planners, also like that, they also use. Then when we talk about the history and the development, then it has a fascinating history that dates back to early 1919 also. So it works early as MRI. I know you are already familiar with that word, MRI or MRI scanner. Am I correct? Yes, good. Now, shall we have how does the fMR detect the activities in the brain? Like that, it can give a high quality visualization of the location of activity. Then as well as it helps to study the natural healthy functions, natural healthy brain functions, as well as it helps to study what are the areas is affected by different diseases like that. Then shall we know about the advantages and disadvantages here as my last part of here. When we talk about the advantages, fMR only uses the normal body features and does not require include any injections or radioactive materials. Okay, it's one the main point. Then the here next it is a non-invasive brain imaging technology, and the experimental design it has. Then the visual acquisition methods also, as well as it has two disadvantages also. One of the biggest disadvantage has to do with fMRI. fMRI is time. Okay, then my last point is then the lack of standardized acquisition and the analysis methods. So thank you for listening for us, and next I thank you very much for listening. Then Nirmani will explain the next method of brain study called as EEG. Over to you, Nirmani.
Thanks, Chanvi. So now we are going to know about a fascinating tool called EEG, which is electroencephalograph. First, we will look what about EEG. So it is a non-invasive neuroimaging technique. So in EEG, you don't have to do any surgeries. That's a good point, right? So the second point, improved with digital technology. Though EEG is an old method which falls back to 1920, it's improved with digital technology. And as you can see in the video, the electrodes are placed on the skull, which is the head, and by that you can measure and report electrical activity in the brain, and by the EEG machine it will record it. So now let's know about EEG's work in studying the brain. Investigates cognitive processes. So what do you mean by a cognitive process? When it comes to it helps to understand things like memory and the attention, and how we understand the language. So next point, event related potentials, which is ERP. So we can see by these means we can see how the things, how the brain reacts to different tasks and events. And the next one, diagnose various neurological conditions and disorders. Can you see the picture over here? So that's an epilepsy patient. So by this, the doctors can diagnose epilepsy and sleeping disorders, traumas, etc. So now let's move on to the advantages of EEG. High temporal resolution, and it gives you a real-time data, and easy and safe. As you can see in the picture, the child smiles. So we use EEG for children. That means it doesn't hurt, right? So it's very simple and it is easy. So by this method, the language studies and the medical uses are there. And next is the good for language and studies. What do you mean by that? So the researchers understand how the brain processes language. Now let's move on to discuss about the disadvantages. As you can see in the diagram, limited spatial resolution. You can see where EEG is in the blue color dot. It has a limited spatial resolution, and it says.
Shall we try to give it to her?
Right. Thank you. So I will hand over this to Subodha. It's your time.
Thank you, Nirmani. Now I'm going to, now we have come to the most interesting part of our presentation, where we are going to compare and contrast these three methods. We have postmortem, fMRI and EEGs. So fMRI allows for a detailed examination in anatomical and neurochemical aspects of the brain. Furthermore, the researchers gave the chance to examine the deeper regions of the brain. And in fMRI, it shows areas involved in different neural activities. So fMRI measures the blood flow of the brain when a person when a person performs a task according to a positive or a negative command. And also it gives the 3D dynamic map highlighting the part as you saw in the previous slides. EEG, it can detect disorders such as epilepsy, Alzheimer and sleeping disorders. So as a second point, we are going to talk about what are invasive and non-invasive methods. Postmortem invasive, of course it is, but it's not a big issue since the person is dead. But there can be ethical issues, as Malsha said.
Shall we now find out?
Okay, as Malsha said, fMRI, EEG, both are non-invasive, no radiations, don't insert instruments for the brain. And postmortem has higher spatial resolutions. fMRI compared to EEG, it has good spatial resolution, like 1 to 2 millimeters, but EEG doesn't have. When it comes to temporal resolution, it's about how quickly a scanner can detect something. Postmortem, we don't have that, but fMRI compared to EEG, it has poor temporal resolution. So now after looking at these three methods, the question comes to our mind, what is the best method to study about the brain? I would say three methods are equally important because they have unique benefits and limitations, and we can use them for various research methods and clinical scenarios according to the requirements. So this is the end of our presentation. Now it's time for you to ask questions if you have, or you can email them to the provided email address. No questions?
Any questions? Okay, so can you just tell me how do you think incorporating all these methods into more practice sessions how something like that could benefit for the language and mind studies that we have studied?
So using
As a team, you can even answer. My question was, how do you think incorporating these methods can put into the language and mind module that we have studied to get a more understanding about the module?
So, using postmortem, you can really observe the brain parts physically, like you can cut and see. But when it comes to fMRI, like when a student give a command to write something, how the thoughts, the brainstorming process happens in the brain, you can detect that using fMRI. Likewise.
I believe that all the three methods could be incorporated to study language, because each method is used to study brain. So even for language it can be used, because we can provide when it comes to the modern techniques, we can use a child or whoever the particular person into providing a task with writing activity or a reading activity related to language while even speaking, and we can identify which areas of the brain lightens up, the language related parts of the brain, and I did study and research more about language related areas of the brain. Even when it comes to postmortem, we can use the dead brain and identify which areas using that, and study in a more realistic way using the brain, the postmortem.
Thank you. Any other questions? Okay, thank you then.